Hello, stargazers and cosmic enthusiasts. Welcome back to our channel where we dive deep into the mysteries of the universe. Today, we're zooming in on Betelgeuse, one of the most fascinating stars in the night sky, which has been behaving in ways that have left scientists scratching their heads. If you're ready to explore why Betelgeuse looks stranger than ever and why physics is being put to the test, then let's get started. A few years back, Betelgeuse grabbed headlines worldwide. The luminary giant started dimming, sparking speculations that it could be on the verge of exploding into a supernova. However, that was just one of the surprises this stellar giant had up its sleeve. Recent findings from the Elmer telescope array reveal that Betelgeuse is spinning at a rate that's hard to wrap your head around. It completes a rotation roughly every 20 years. While that may seem slow for a star of Betelgeuse's magnitude, it means its surface is whirling at speeds of 18,000 kilometers per hour, or about 5 kilometers per second. To put that in perspective, that's 10 times faster than any speed we experience here on Earth's surface. For a massive supergiant like Betelgeuse, these speeds are nearly breaking the laws of physics. Let's start with the basics. How do we measure the rotation of celestial bodies? For objects like the sun, the moon, or planets within our solar system, it's straightforward. You can simply point a telescope at them and observe their features moving in real time. For example, the angular diameter of the moon is about half a degree, and you might even spot its features with the naked eye. Jupiter's angular diameter is 1/100th of a degree, but even at that size, its bands and moons are distinctly visible through a telescope. But what about Betelgeuse? This red supergiant, although massive, is located a staggering 650 light-years away. Its vast distance makes its angular diameter 1,000 times smaller than Jupiter's, reducing it to a mere speck in even our most advanced telescopes. Fortunately, astronomers have a clever workaround to measure rotation in such cases, and it involves a concept you may have heard of, the Doppler effect. This technique may be less direct than simply observing the star, but it's an ingenious method that allows us to probe the secrets of stars light years away from us. Stay with us as we dive deeper into this fascinating topic and discover more about the unusual surface of Betelgeuse and the secrets behind its seemingly impossible rotational speed. You're watching Astronomy. Let's explore the cosmos together. Let's delve into a fascinating phenomenon that's as relevant in the cosmos as it is in our everyday life, the Doppler shift. You've likely experienced this effect firsthand if you've ever heard an ambulance wail change as it zooms past you. When the ambulance rushes towards you, the siren's pitch sounds higher because the sound waves are compressed, hitting your ear more frequently. But as it speeds away, the pitch drops, since the sound waves stretch out and hit your ear less often. What's less noticeable but equally intriguing is how this same principle applies to light waves. As the ambulance approaches, the light waves it reflects are compressed, making it appear slightly bluer. Conversely, as it moves away, the light waves extend, giving it a slightly redder tint. This visual effect is subtle because light travels 1,000,000 times faster than sound, making the color shift almost imperceptible unless the ambulance were moving incredibly fast. Now, imagine if we could see such shifts more clearly. In space, we do. Objects like stars don't need to reach the fantastic speeds of light to make their color shifts noticeable. That brings us back to Betelgeuse, a star whose massive size and rapid rotation allow us to observe these shifts. When a star like Betelgeuse rotates, one half that turns toward us blue shifts slightly, while the other half, moving away, red shifts. Imagine a giant celestial canvas swirling in space, its surface a mesmerizing dance of colors. This is the phenomenon we observe in stars like Betelgeuse. As this immense star rotates, one half of its surface moves towards us while the other retreats. This motion creates a captivating gradient of colors, which, though the star itself may appear as a blur through our telescopes, reveals profound secrets about its behavior. When we observe the side of Betelgeuse that appears bluer, we know this half is rushing towards us. The redder side, conversely, is moving away. This color shift, subtle yet revealing, allows astronomers to determine the direction of the star's rotation. By analyzing the variance between the bluer and redder frequencies, we can even calculate the star's rotational velocity. This technique was crucial in allowing astronomers, using data from the ALMA observatory, to conclude that Betelgeuse's surface spins at an astonishing 5 kilometers per second. Now here's where things get truly mind-boggling. According to conventional physics, 5 km/s is an unexpectedly high velocity for a red supergiant like Betelgeuse. Consider our Sun, which, despite being 1,000 times smaller and about 10 times lighter than Betelgeuse, rotates at roughly 2 km/s. If we were to magically expand the Sun to match Betelgeuse's size, enveloping the entire inner solar system up to nearly Jupiter's orbit, its rotational speed would plummet to just 2 meters per second to conserve angular momentum. Imagine a spinning ice skater who gracefully slows as she extends her arms. This is how angular momentum works even among the stars. According to this principle, as a star like our Sun expands, its rotational speed should decrease dramatically. Indeed, if the Sun grew 10 times heavier to match Betelgeuse's mass, its spinning velocity would drop to a mere 0.2 meters per second. Generally, the larger and heavier a star, the slower it spins. Yet Betelgeuse shatters these expectations, spinning at velocities that boggle the mind. So, what's the secret behind this cosmic enigma? One thrilling theory suggests something out of a celestial horror story: stellar cannibalism. This phenomenon isn't as rare as you might think. It occurs in binary star systems where one star devours its companion. As it absorbs the companion's gaseous outer layers, it also inherits its angular momentum, causing the cannibal star to spin much faster than it otherwise would. Could this be the tale of how Betelgeuse gained its rapid spin? Or is there a deeper, more mysterious force at play? Some researchers from a collaborative team spanning Europe and China propose that what we perceive as Betelgeuse's rapid rotation might actually be a colossal optical illusion. To explore the possibility of a grand optical illusion surrounding Betelgeuse's rotation, let's revisit the findings from the ALMA team. Using their advanced telescopes, they observed that while Betelgeuse appears blurred, one half of the star emits slightly redder frequencies of light, while the other appears bluer. The straightforward interpretation? The star is rotating, with one side moving towards us and the other moving away. But hold on. What if there's more to this story than simple rotation? Let's consider another tantalizing possibility. Simulations of Betelgeuse have shown that its surface is not a tranquil sea, but rather a stormy ocean of chaos, roiling with turbulence caused by intense heat. This star's surface behaves more like water boiling fiercely in a pot, with each bubble of hot gas as enormous as they come, some spanning up to 100 million kilometers across, covering vast expanses of Betelgeuse's surface. Imagine one of these colossal bubbles rushing towards you at speeds reaching 30 kilometers per second. No spacecraft in existence could outrun it. This tumultuous activity could also contribute to the varied light frequencies we observe, offering an alternative explanation to the assumed rotational speed. In the heart-pounding theater of cosmic phenomena, imagine if the only escape from an oncoming cataclysm were for a monstrous bubble to pop and violently collapse back onto the surface of Betelgeuse before it could reach us. As these gas bubbles surge and plummet, the surface of Betelgeuse transforms into a dynamic mosaic of regions constantly shifting towards and away from us. This relentless motion induces the Doppler shift, causing the light from these regions to oscillate between being blue-shifted and red-shifted. In a groundbreaking recent paper that has shaken the foundations of our understanding of Betelgeuse's rotation, an international team of researchers has proposed a radical new theory. Perhaps Betelgeuse isn't rotating at an incredible speed after all. According to their analysis, the diverse range of light frequencies observed by the ALMA telescopes might actually stem from the intense turbulence on the star's surface. This suggests that astronomers may have been misinterpreting these shifts in frequency as signs of rapid rotation. For those of you keenly following the physics, you might spot an intriguing discrepancy with this alternative explanation. Traditionally, a rotating star should exhibit a smooth gradient of light frequencies. transitioning seamlessly from bluer than expected light on one edge to redder than expected light on the other. In contrast, a turbulent star like Betelgeuse would likely display a chaotic, patchwork array of colors. Imagine a celestial canvas with patches of blue, where massive bubbles rise, and swaths of red, where they collapse back down into the depths of Betelgeuse. Given such a vivid, dynamic scenario, how could astronomers possibly confuse this with the smooth gradient indicative of rotation? If astronomers observed a clear, linear transition of colors across Betelgeuse, the theory of a chaotic bubbling surface might be dismissed outright. In an ideal world, gradients would indeed signify rotation, while a patchwork of colors would clearly point to turbulence. However, the reality of observing a star so distant and vast as Betelgeuse complicates matters. Through the lens of ALMA's telescopes, which offer groundbreaking insight yet cannot produce an image as crisp as an HD photograph, Betelgeuse appears more as a blur. Simulations taking into account this limited resolution suggest that what appears to be a smooth rotational gradient could be misleading. These simulations show that the tumultuous patches of red and blue shifts caused by the star's boiling surface could be mistaken for a rotational gradient about 90% of the time. This implies that even with flawless analysis, astronomers could be deceived by the star's turbulent nature into believing it spins much faster than it actually does. This revelation has steered astronomers towards a new, critical goal, obtaining higher resolution observations of Betelgeuse. Such advancements could finally clarify whether the star's perceived rapid rotation is real or just another layer of its mysterious, turbulent charm. We have some thrilling updates about Betelgeuse, alongside a tantalizing question for all you cosmic enthusiasts out there. The good news? We've got sharper images of Betelgeuse, captured by the same telescope, but with extended exposure times, promising a clearer view of this enigmatic star. The catch? Patience is key, as it will likely take a couple of years to thoroughly analyze these images. But rest assured, answers are on the horizon. Now, I turn to you, our curious viewers. Where do you stand on the spinning saga of Betelgeuse? Do you think it's hurtling at 5 kilometers per second after possibly devouring its companion star? Or could this perceived rapid rotation merely be an optical illusion, a trick of turbulent gases on its surface? Share your thoughts and theories in the comments below. I'm eager to see where you place your bets. One of the most exhilarating aspects of hosting Astrum is the opportunity to dive deep into various cosmic mysteries, transforming complex topics into engaging videos. The universe never ceases to amaze with its vast array of mysteries and revelations. Though my role here keeps me on my toes with endless discoveries, I must confess, there's hardly enough time to quench my thirst for knowledge. That's why I'm thrilled to introduce today's sponsor, Imprint. Imprint offers an innovative app designed to fit learning into any schedule, no matter how hectic. It's filled with concise, impactful lessons that make daily learning effortless. I personally started with a course on leadership skills and have now delved into astrophysics for people in a hurry. It's perfect for staying intellectually stimulated, even during a packed day. Exciting news, Astrum fans! I've been diving deep into the origins of our universe with the help of Imprint, our sponsor for today's episode. Imprint has rejuvenated my understanding of the Big Bang with chapters filled with engaging visuals and interactive questions designed to sharpen your focus and make learning a thrilling journey. Plus, there's something incredibly satisfying about keeping up a learning streak. I'm hooked, and I know many of you are too. It's no surprise that Imprint was named Google's App of the Year. If you're inspired to build a daily learning habit, why not start with Imprint's 7-day free trial? Just click the link, imprintapp.com, Astrum in the description below, or scan my QR code right here. As a special thank you to our Astrum community, you'll get 20% off the annual premium subscription with Imprint. So why wait? Dive into learning today. A big shout out to our viewers, especially Enigma, Ali, and Daryl, for your insightful contributions, and a heartfelt thank you to our Patreon supporters, our astronauts, who fuel this channel. Our Patreon community is a vibrant space where I love to engage with your thoughts and feedback. If you're not an astronaut yet and want to support us beyond the whims of algorithms, check out the link in the description. Joining gives you ad-free viewing, your name in the credits, and the chance to submit questions directly to our team. Betelgeuse is not just another twinkling celestial body. It's a red supergiant nearing the end of its life, located in the constellation Orion. Known for its distinct red color and massive size, Betelgeuse is one of the largest stars visible to the naked eye. Typically, red supergiants are known for their predictable late-stage activities, but Betelgeuse has been full of surprises, exhibiting unusual dimming and brightening patterns that have intrigued astronomers worldwide. In late 2019, Betelgeuse started to dim significantly, which led to speculation that it might be about to go supernova, an explosive end to a star's life. This dimming was unprecedented. Betelgeuse lost more than 2/3 of its brightness, becoming one of the darkest periods observed in its history. Theories ranged from dust clouds covering the star to significant changes in its internal structure, challenging our understanding of stellar physics. The physics of supergiants is complex, involving a delicate balance of gravitational force and nuclear fusion. Betelgeuse's behavior has posed a significant challenge to these established theories. Some scientists propose that the star might be cooling and contracting, which could precede a supernova explosion. Others suggest that the dimming could be due to an enormous amount of dust ejected by the star itself, which obscures its light. Recent observations by telescopes like the Hubble Space Telescope and ground-based observatories have provided more clarity but also more questions. Images captured showed that the surface of Betelgeuse is unevenly bright, suggesting large-scale surface activity. This activity includes massive convective cells turning over and possibly gigantic plumes of gas being ejected into space. Betelgeuse's unexpected behavior is more than just a cosmic spectacle. It's a valuable lesson in astronomy. These observations provide a unique opportunity to test and refine our theories about the life cycle of stars, particularly the massive ones. Each new piece of data helps astronomers better understand how stars evolve and what signs might precede their explosive demise. The behavior of Betelgeuse has implications not just for the star itself, but for the surrounding space. As a star nearing the end of its life cycle, Betelgeuse's activities could affect interstellar material in its vicinity. Ejected material from the star, such as gas and dust, can contribute to the formation of new stars and planets in its neighborhood. Understanding these processes helps astronomers predict changes in local cosmic environments. The study of Betelgeuse has been bolstered by technological advancements in astronomy. Instruments like the Atacama Large Millimeter, Submillimeter Array, ALMA, and the Very Large Telescope, VLT, have allowed scientists to observe the star in unprecedented detail. These technologies help capture high-resolution images and spectra, providing critical data to study the star's surface and changes over time. Betelgeuse is not the only supergiant that exhibits unusual behavior, though it is one of the most studied. Comparing Betelgeuse with other similar stars, such as Antares in the Scorpius constellation, provides context for its activity. These comparisons are crucial for identifying whether Betelgeuse's behavior is unique or a normal part of supergiant life cycles. Amateur astronomers play a crucial role in monitoring Betelgeuse, providing valuable data through continuous observation. Their contributions complement data from professional telescopes, creating a more comprehensive understanding of the star's behavior. This collaborative effort between amateur and professional astronomers enhances the overall field of stellar astronomy. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, You will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blisovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.